Hello learner, my name is Dickens and we are looking at precipitation reactions in today's lesson. Let us start by defining what is a precipitation reaction. So a precipitation reaction is what type of reaction? So precipitation reaction. So you'll realize that we have some reactions which take place, and one of the products that comes out is normally a solid. So such type of reactions in which a solid is formed as a result of reaction between two salt solutions, such kind of reaction is called a precipitation reaction. And in most cases, the two salt solutions will be both soluble in water. So I'm saying that a precipitation reaction is a reaction in which solid particles, and these solid particles are the ones we're going to call a precipitate. Precipitate are formed as a result of a reaction between two salt solutions. That means whatever I'm reacting, I'll have two salt solutions. The two solutions will react by exchanging their ions. When they exchange their ions, we shall form a solid, and that solid that we shall form is called a precipitate. And the process of formation of a precipitate is what we are calling a precipitation reaction. So I want us to consider the following reaction. For example, if you react lead nitrate, as we know very well, lead nitrate is a soluble salt. When lead nitrate is reacted with sodium sulfate, the two salt solutions will react by exchanging their ions. So the product will be the sodium, the nitrate will exchange with the sulfate. As a result, we shall form lead sulfate. As we know, lead sulfate is an insoluble salt. Therefore, it will come out as a precipitate. So this is the one we are calling a precipitate. It will come out in solid state, and the other product will be sodium nitrate. So we are saying this is an example of a precipitation reaction because it involves the reaction between two salt solutions. And remember, the two salt solutions must be both soluble in water. So we know lead nitrate is soluble as well as sodium sulfate. So the two salt solutions react and exchange their ions. Then we shall get lead sulfate and sodium nitrate as the two products. Remember, they are formed as a result of exchange of the two particular ions. So in real sense, our precipitate will be lead sulfate, and the process, this reaction, we call it a precipitation reaction. Another example is the reaction between lead nitrate. We can use lead nitrate. Lead nitrate can still react with potassium carbonate. When lead nitrate reacts with potassium carbonate, don't forget, potassium carbonate is a soluble salt. Lead nitrate is also a soluble salt. So the two salt solutions react when they are mixed together and exchange their ions. We shall get the following products. We shall get lead carbonate. which is insoluble. So this will be our precipitate, the solid that will come out of that reaction, precipitate. The other product will be potassium nitrate. So the two salt solutions, like you have said, react by exchanging their ions. Don't forget to balance the equation. So let us balance this one here. Lead atoms, this is 1, 1. Nitrate, these are already 2, so I put here 2 so that I can balance the equation. Our first equation, we also balance it in the same manner. We put a 2 on sodium nitrate. So that's another example of a precipitation reaction, which involves the reaction between two soluble salts. The two soluble salts react and exchange ions and produce an insoluble salt and a soluble salt. Another example, it can be the reaction between lead. We have quite a number. So long as you pick two soluble salts, then you should be able to get the products. We have another salt here called potassium iodide. Potassium iodide reacts with lead nitrate. The two react by exchanging ions. Then we shall get lead iodide, which is a solid. Don't forget there is a 2 here, a solid, and this solid is yellow in color. It's good we know the color. It's yellow. Plus the other product is, remember they are exchanging their ions. The other product is potassium nitrate. So we balance the equation. I'm having one potassium atom, but I have one iodine atom on the left, 2 on the right. So I balance by putting 2 here. So the 2 means I will have 2 potassium atoms, but remember this side has 1. So I balance by putting here 2. So therefore the equation will be balanced. Once again, we are saying these are examples of precipitation reaction. And you have said during precipitation reactions, salt solutions, and in this case we are talking about soluble salts, react by exchanging their ions, and as a result we get a solid, which is the precipitate, and the other insoluble salt. So during the reaction we need to notice this, that we have some of the ions during the reaction that do not undergo a change, while others will undergo a change. That brings us to the definition that we need to know. We are talking about is spectator ions. So now we are saying during precipitation reaction, we have seen salt solutions react by exchanging ions. And in the process, we have some ions which remain unchanged during the reaction. So such type of ions, we call them spectator ions. So how do we define them? These are ions which remain chemically unchanged during a chemical reaction. So ions which remain chemically unchanged during a chemical reaction. So in essence, spectator ions do not normally take part during a chemical reaction. So that's another property that we need to know, that they don't take part in the reaction. That's why we are saying the fact that they don't take part in the reaction they'll remain unchanged. They remain at the start same, at the end they'll be the same. So we call them spectator ions. So we need to know this, that spectator ions are normally very important as far as writing ionic equations are concerned. Writing ionic equations, they are very important when writing ionic equations. From the word ionic equation, we are saying these are equations in which we only write the ions. And the ions we are writing are the ions which are taking part in the reaction. The ones which don't take part, we have said we call them spectator ions. And these ones, we omit them when writing ionic equations. But those which take part in the reaction, we call them, we have to write them when writing the overall ionic equation. So ionic equation simply is an equation written only with ions that take part in the reaction. Ions that take part in the reaction. Those which don't take part, we have said they are called spectator ions, and those ones are omitted when writing ionic equations. So spectator ions are omitted when writing ionic equations. So remember, we have said from the word ionic, we are just writing equations using ions only. And the ions we are writing are the ones that are taking part in the reaction. Those which don't take part in the reaction, we have said we are calling them spectator ions, and therefore those ones are omitted when writing ionic equations. So having said that, I want us to use these equations of precipitation reactions to write ionic equations. So our next concept is writing ionic equations. So let me start by giving you brief steps that you need before you write any ionic equation. So the first thing you do is you cannot write an ionic equation before you write the chemical equation. So step number one, write a balanced chemical equation. So you first of all begin by writing the chemical equation. From it, you can use it to now get the ionic equation. Then second point, split the compounds which are in aqueous state into their constituent ions. That's why we are saying it's very important you have the chemical equation so that you can tell which compound are you going to split its ions. Remember, the condition is here, you only split those compounds which are in aqueous state. If the state symbol is solid, liquid or gas, then you don't split the ions when writing the ionic equation. The third very important step when writing ionic equation is identify the spectator ions and cancel them, or you omit them in the final ionic equation. So these steps will guide us in writing the ionic equation. So let us start by the first example. Remember, you are learning about writing ionic equation. We shall use those precipitation reactions so that we can get the point well. So we want to write the ionic equation for the reaction between lead nitrate and sodium sulfate. So we have said the first step, you write the chemical equation. So it is lead nitrate, state symbol aqueous, plus sodium sulfate, state symbol aqueous, that will give you lead sulfate, plus sodium nitrate. So state symbol is aqueous. This is the precipitate, so the state symbol is solid. So don't forget to balance. This will be 2, like that. So step number 1, write a balanced chemical equation. We have done. Step number 2, you identify the compounds which are in aqueous state. In this case, you should be conversant with the knowledge of solubility. It's very important, especially when writing the state symbols of compounds in a reaction. So this is lead nitrate, it is aqueous. Sodium sulfate is also aqueous, but lead sulfate is solid. This one is aqueous. So you have said you split those ones which are in aqueous state, the ions into their constituent, the compounds into their constituent ions. So lead nitrate contains lead ions and nitrate ions. Those are the ions which I'll write here. So lead ions, this I write lead ions, aqueous, and nitrate ions. From the equation, I'm having 2 nitrate ions. So I put here 2. Remember, it is aqueous, plus this one here. Sodium sulfate, I'll have 2 ions. I'll have sodium ions and sulfate ions. Those are the ones I'm going to write here. Sodium ions, aqueous, and sulfate ions, aqueous. Remember, we said the state symbol should be aqueous before you split. From the equation, I'm having 2 ions of sodium, so I'll put here 2. Then the result will be what? The state symbol, lead sulfate. So this one will remain. Lead sulfate is solid. So this one, the ions are not split, but this one aqueous. So we are going to have 2 ions, sodium ions and nitrate ions. So from the equation, I'm having 2 sodium ions and 2 nitrate ions. So that should be captured correctly. Sodium ions aqueous plus 2 nitrate ions aqueous. Remember, we have said split those compounds into their ions, those compounds which are in aqueous state. Then the next step is identify spectator ions. Remember, we have said spectator ions are ions which remain chemically unchanged. So the easiest way of telling those which are chemically unchanged is you just look at the equation, the one you have just written, check lead ions on the left are in aqueous state, but in lead sulfate, it's solid. That means these lead ions have undergone a change from aqueous to solid. Therefore, lead ions are not spectator ions. Remember, you have said spectator ions remain chemically unchanged. Next, you check nitrate. I'm having nitrate ions at the start. They are in aqueous state. At the end, they are also in aqueous state. So the nitrate ions are spectator ions because they have remained unchanged, chemically unchanged. At the start in solution state, at the end also in solution state. So therefore, these nitrate ions, we call them spectator what? Ions. So we shall cancel nitrate ion on the left and nitrate ion on the right. Then the next, you move to sodium. Sodium ions on the right, on the left, aqueous state. Sodium ions on the right, aqueous state. So these ions at the start aqueous state, at the end aqueous state. That means they have not undergone any chemical change. As a result, we shall also refer to them as spectator ions. So we also cancel sodium ions, spectator ions, we cancel. Lastly, check sulfate. At the start, aqueous, but here it is solid. That means the sulfate ions have undergone a change from aqueous to solid. Therefore, those ones will not be cancelled. They are not spectator ions. After which, after identifying the spectator ions and then cancelling them, you now write the ionic equation, omitting the ions you have cancelled. So this will be the final ionic equation. We shall have lead ions aqueous reacting with the sulfate ions aqueous, and that will give you lead sulfate solid, and that will be our ionic equation. Let us look at another example of ionic equation. We shall still use the equation we wrote, the precipitation equation we wrote earlier. Okay, so our equation was lead nitrate aqueous reacting with the potassium carbonate aqueous. Remember, we have said such a kind of a reaction, we call it precipitation because the two are soluble salts. They react by exchanging ions. So our product will be lead carbonate, which is insoluble. So therefore we put S plus potassium nitrate. So this one is aqueous because it is a soluble salt. So we balance, we put here 2. After that, you identify the compounds which are in aqueous state. In this case, we have lead nitrate, potassium carbonate, and potassium nitrate. So those compounds are the ones we are going to write their ions. So this will be lead nitrate will contain 2 ions. We shall have lead ions aqueous and nitrate ions aqueous. The 2 should be put here, plus potassium carbonate. We shall have 2 ions, potassium ions and carbonate ions. So potassium ions aqueous, there are 2, so I put here 2, plus carbonate CO3, 2 minus carbonate ion. The result, lead carbonate, will remain. We don't split the ions. Remember, we said split those ones which are in aqueous state. But if the state symbol is solid S, L or G, you don't split, as we are going to see in our next example. Potassium nitrate, we shall have 2 ions. We shall have potassium ions. There are 2 aqueous, and nitrate ions, NO3. There are also 2 minus. After that, you identify spectator ions. Remember, we have said spectator ions are ions which do not take part in the reaction and remain chemically unchanged. So the easiest way, you check, start with lead. At the start, it is in aqueous state, but in lead carbonate, the ions are S. So it means lead has undergone a change. Come to nitrate, it's aqueous at the start. This side is also aqueous. That means nitrate has not undergone any change. Therefore, it's a spectator ion. So we cancel this one and that. Next, come to potassium. Check on the left, aqueous. On the right, aqueous. So potassium has not undergone any change. Therefore, it's also another spectator ion. So you cancel potassium and potassium like that. Then carbonate. Carbonate at the start equals, in lead carbonate, solid. That means carbonate has undergone a change from aqueous to solid. Therefore, it is not a spectator ion. After that, you now rewrite the equation, omitting the ions that you have cancelled. And the equation we shall have written will be as follows. So we're going to have lead ions combining with the carbonate ions equals, and that will give you lead carbonate solid. So this type of equation, we call it ionic equation. Let's look at one more. The reaction between lead nitrate aqueous and potassium iodide. Remember, this is also another example of a precipitation reaction. We shall get lead iodide, which is an insoluble salt, plus potassium nitrate, which is a soluble salt. We balance, we put 2 on potassium iodide and 2 potassium nitrate. The equation will be balanced. After that, you identify the ones that are in aqueous state and split that compound into its constituent ions. So this compound lead nitrate will contain the ions of lead aqueous and the ions of nitrate. There are 2, so the 2 is written here, aqueous plus this one. I'm having 2 potassium ions aqueous, and also 2 iodide ions aqueous. That will give you check the state symbol S, so it will remain PbI2 solid, and then plus potassium nitrate has 2 ions. We have 2 potassium ions aqueous and 2 nitrate ions aqueous. After that, you identify the spectator ions, the ones that we have said they remain chemically unchanged. So you start lead at the start aqueous, the end solid. So lead has undergone a change, come to nitrate, at the start aqueous, at the end aqueous. So nitrate, as you can see, ions, they have not undergone any change. Therefore, they are spectator ions. So we cancel nitrate and nitrate. Come to potassium. Potassium at the start aqueous, at the end aqueous. They have not undergone any change. Therefore, they are also spectator ions, so we cancel. Lastly, iodide ions at the start aqueous, at the end solid. So iodide ions have undergone a change. Therefore, they will not be cancelled. So after that, you now write the overall equation, omitting the ions that you have cancelled. So the equation will be as follows: lead ions aqueous plus 2 iodide ions aqueous. The product will be lead iodide solid. So that will be the overall ionic equation. So learner, we are saying we have learned precipitation reactions, and from it we have been able to learn how to write ionic equations. So we have said during a precipitation reaction, 2 soluble salts react by exchanging their ions, and the result will be a soluble salt and an insoluble salt. That insoluble salt will be called a precipitate. Then from there, we have been able to learn how to write ionic equations. We have said ionic equations are equations that are taking part in the reaction. Those which don't take part in the reaction, you have said, we call them spectator ions. So having said that, I would like you to try the following questions. Try the following questions as part of your exercise. Questions. First question, define spectator ions. First question is you're supposed to define spectator ions. Second question, define precipitation reaction. Second question, you define what the term precipitation reaction means. Third question, write ionic equations for the following precipitation reactions. You are supposed to write ionic equations for the following precipitation reactions. The first precipitation reaction is the reaction between silver nitrate reacting with sodium chloride. So you get the products, and then from the products you'll be able to write the ionic equation. The next one you also try is the reaction between copper 2 chloride, and sodium carbonate. Remember, we have said precipitation reactions involves reaction between two soluble salt solutions. Then we get an insoluble salt and a soluble salt. So these two are still precipitation reactions. So you'll get the products. After getting the products, you try and write the ionic equation. Our last question, which I want you to try, is the reaction between barium nitrate reacting with zinc sulfate. That is still another example of a precipitation reaction. So try those three questions. Ionic equations: silver nitrate reacting with the sodium chloride, copper chloride reacting with the sodium carbonate, barium nitrate reacting with zinc sulfate. Remember, we said during the reaction, the salt solutions will react by exchanging their ions. So you try and get the products, and then from the products, you try and write the ionic equation. Otherwise, we have come to the end of our lesson. I want to thank you for being a good student, and I'll see you in our next lesson. Thank you so much.